Today we will be looking at Python data structures. So we look at lists, we look at tuples, we look at sets and dictionaries. So let's get started. So we are going to start with lists. Let's create a file called lists.py. And what are lists? Before even we create the first list. Lists are ordered. First, you must know that they are ordered, mutable collections of items, so they can be changed. And how do you create your first list? This is how you creating a list. So, for example, a list fruits. You can have apple. You can have banana, and you can also have cherry, or any other fruit that you want. So that is how you create a list. So that is a list for you. And then how do you access? For example, let's try access banana. Access banana. So remember, this lists have indexes also. So apple is index 0, banana is index 1, and cherry is index 2. So how do you access banana with that information? This is how you access banana. So what is the list? The list is fruits. And then what index is banana in? Banana is in index 1. So let's see what that produces. Lists. You can see banana at index 1. So let's go ahead and modify the list items, because remember we said lists are ordered and they are mutable. So we can try and change fruits as index 1, banana, that was banana. Let's give this blueberry. Let's print fruits and see. Print fruits. Just comment that out. Let's see apple, blueberry and cherry, because we have changed the fruit that is on index 1, which was banana, to blueberry. Then how do we add or remove items into the list? So we can either append or remove. Let's try and append. So add or remove. Let's try and add an orange into the fruits. So fruits dot append. So you use append to add a fruit. So we can have orange. So that is what you use to add. And then let's try and remove. We remove blueberry. Let's see what it does. Let's print fruits. So save that, clear here, run that. So apple, cherry and orange. So we added orange and we removed blueberry, which was in the original list. So how about slicing of lists? So for example, we might want the fruits from index 1 to index 2 or index 3. Let's see how we get that. So let's comment that out. Let's get fruit, because we have apple, cherry and orange. Let's get apple and cherry. So that is index 0, index 1, and this is index 2. So let's have a sublist. You can have fruits, then slice from index 1 to index index 1 to index 2. I think this should return 1, just one fruit. Let's say print sublist. Let's see. It should just return cherry, because we want from index 1, apple is index 0, cherry is index 1, but we want up to index 2, so we do not include the second one. But if I think we had 3 here, because we don't have index 3, let's see. I think that should include cherry and orange. So that is how you break down or slice lists. So you can go and try and calculate the average of a list of numbers. So that is an example that you can take a second and try and do before you check the solution that we have. So I want to comment this out. Let's do that. Let's create a function. Remember, we did functions in our second class, so you can go and try and go through it or check how we did it. So we need average of numbers. So our list will be the numbers. So then what we return from our function is just close that. From the average, you need to return the sum of numbers, because what you're looking for is calculate the average of a list of numbers. So you have to divide by the length of the numbers, because that is how you get the average. Calculate average of numbers. So that is the function. So now let's pass a list of grades. So we can have integers 80, integer 90, 85, 95. We can also have 78. So let's print average, which is the function, and then what we pass as the numbers, grades. Let's see. I need to close that, I need to close that, and I need to run that. So I get 85.6, which gives me the average of the list of numbers. Because you can see I have a function here, average, which takes the sum of numbers and I divide by the length of the numbers. And then I pass my grade as the numbers. So it will be 80 plus 90 plus 85 plus 95 plus 78 divided by 1, 2, 3, 4, 5 divided by 5. So that is lists. Let's go ahead and look at tuples. And tuples are ordered, but they are immutable collections of items. Remember, lists are mutable, but tuples are immutable. So tuples.py. You can just close this. So remember, these are immutable. They are ordered, but they are immutable. So let's create a tuple. For example, a coordinate. From a good example of a tuple, you can have 4, you can have 5. That is a coordinate. Then how do I access the tuple? It's the same thing as we were doing with the list. So coordinates, and then what index we have? We have index 0. Which will give me, what will it return? It should return 4. Let's see if that is what it gives back. Let's delete that. So Python tuples.py 4. So index 0, index 1. So it's always nice to note that. So let's give just a simple example of calculating the distance between 2 points using a tuple. So let's comment this out. Calculate the distance between 2 points. So try it out before you use my solution. So I need to use math. So remember, when looking at modules, we went through math. So you can check that out, and then let's create a function distance. Then we can have 0.1 and we can have 0.2. So that is our function, and we need to return math dot with the square root with 0.2 index 0. Then we need, that should be right, we need 0.1. Remember, we are calculating the distance between 2 points. So 0.1 at index 0, and then we multiply it by 2. Then we need to do plus. We now to do the other one. So 0.2 at index 1 minus 0.1 at index 1, then times what? It's 2. And just combine this should not have any effect. So what we want is 0.2 at index 0 minus 0.1 at index, because we'll obviously have two coordinates, either 2, 3 or 6, 6 for 0.1 and then 0.2, because they're two coordinates. So we need to find the difference between the first index and so this is 0.2 at index 0 and then 0.1 at index 0. And then you multiply it by 2, and then we have 0.2 at index 1 and 0.1 at index 1. And then we have it multiplied by 2. But let's see if it returns what I expect. So 0.1 to be equals to, let's say 2, 3. Then we can have 0.2 to be 6, 6. Then I need to find the difference now. So I'll use the function distance. What do we use? 0.1, and I need to pass 0.2. Let's see. So the moment of truth. Let's see if a function does what I expect. So I get 3. So you can see this is the square root of 0.2. 0.2 at index 0, this will be 2. And then minus 0.1 at index, so this is 6 minus 2. So we are assuming 0.2 is farther away than 0.1. So 6 minus 2, and then we get, I think I made a mistake here. Instead of this being here, this should be here, because I want to do the subtraction first and then I do the square. So even this one, I think this one should be okay. Let's see if it gives me, yeah, that should be correct now. So 0.2, so 6 minus 2, which is 4. 4 squared is 16, and then 6 minus 3, that is 3. 3 squared is 9. 16 plus 9 is 25. 25 square root of 25 is 5. Yeah, so that should be correct. So that becomes a difference between the 2 points. So that is how you calculate the distance between the 2 points. But you can use any other example that you want. I just wanted to show you how to use the tuples, because you can see 0.1 and 0.2 are coordinates, which are tuples. So we have looked at lists, we have looked at tuples. Now let's go ahead and look at sets. So remember, lists and tuples are ordered. Lists are mutable, but tuples are immutable. Sets are unordered and mutable collections of unique items. So sets must be unique, but they are also unordered. So you have to note that difference. So sets I. So let's create a unique set. We can create unique numbers. So sets can't have a similar number. So let's just 1, 2, 3, 3. That's a set. Let's print that unique numbers. Let's see. Python sets. You can see it gives me 1, 2, 3, because 3 and 3 are similar, but sets have to be. So we say they are unordered, but they have to be unique. So sets have to be unique. Those are the 2 key points. They are unordered, but they have to be unique. So note that. How do we add and remove items from a set? What do? We use the add and remove. So remember, on lists we used the append and remove, but on sets we use the add. So let's add a number 4, and then unique numbers. Let's remove. Let's remove 1 and see. So instead of this being here, let's put it here. And then we clear that and that. So 1, 2, 2, 3, and 4, because we have removed 1 and we have added 4. So finally, let's go ahead and look at dictionaries. So what are dictionaries? Dictionaries are unordered collections of key value pairs. So there is the difference between a set and a dictionary. A set is unordered also, but is not key value pair. But for dictionary, it's a key value pair. So dictionaries dot py. These are key value pairs. Key value pairs. That's the easiest explanation that I can give. So let's create one. For example, a person. Person has various attributes. For example, you could have a name. Your name could be Breton. Have an age, and your age could be an integer. So let's say like 14 years. So that is a dictionary of a person. So how do we access dictionary values? For example, let's say we want to print out the name. How do we do that? We have the dictionary person, and then we have the key is name, because what we want to access is the value. So let's see. So Python, I can use dictionaries. Breton. So we have a key. This is the name is the key. This is the key. The age. This is the value. The value. So no, dictionaries are key value pairs. So how do we modify a dictionary? For example, we can try and modify the age of this person. So let's go for person. Then how do we access it? The key is age. Let's set the age to something like 45. Then let's try and access the age instead of the name. Clear. So that's how you modify. So you can see the age is 45 and we had set it to 14. So dictionaries, that is how you deal with dictionaries. They are key value pairs. So we have looked at lists, we have looked at sets, we have looked at tuples, and we have finally looked at dictionaries. And I would like to leave a simple exercise with you guys. So do this: count the frequency of words in a sentence using count frequency of words in a sentence using whatever we have learned today. So you can pause the video a bit and then try and do it. So I'll create a function definition, and then what do we call it? We call it a word count. Then the sentence that we will give, because we want to count the words in the sentence. And then for words, that will be equal to sentence dot split. We already used this function before, split. Then what else do you want to do? We want the word frequency. Word frequency will be equals to an empty dictionary. That is the dictionary. Then for word in words. So words, the one we have just splitted, and then word is equals to word dot lower. So I need to put it into lowercase. So that is okay. And then if word in word underscore frequency, I'll do word underscore frequency. And what do I do? Word. Then I make an addition so that it gets incremented 1. So that's the if. So it has to have an else statement. Remember, we looked at conditionals last week. So if it's already present, the word frequency, because we are trying to check, for example, how many ins are in a particular sentence. So word, and then obviously because 1. So if it's already present, and then let's do what? Let's return word frequency. No, not word count, but word frequency. So I hope you're understanding this. So the sentence, let's pass. This is a test sentence. Count the frequency of words in a sentence. I just want to use the same sentence. So let me break this here, Alt Z. Then let's try and get the count. Let's see if it works. So the function is word count, and then what do we pass? Let's pass in the sentence. So let's see. So this is a test sentence to count the frequency of words in a sentence. Let's see. We see how many words we get. These, I don't want to have this still. So you can see this is one, is one, test one, sentence two, one, count one, there one, frequency one, of one, words one, in one. So it will count, it gives back a dictionary of the words and their frequency, because you can see we had the function word count, and then we pass in the sentence, which is the variable that we have passed here at the end. So words, so we split the sentence, and then we do a word frequency. Word frequency is a dictionary, and then we loop through the words using a for loop. So for word in words, so words, which is a splitted sentence, and then word is equals to word dot lower, so we can turn them all into lowercase. And then if word in word frequency, make sure word frequency, and then you add or you make an additional. So if it was one, you make them two. If it was two, you make them three. Else, if it's already counted, just leave it as it was, and then return word frequency. So you pass a sentence, and then you pass the function, and you're able to do that. So guys, that marks the end of our class on Python data structures. Make sure you go through it again so that you may be able to understand everything that we have done. Bye bye.